Today we're working on greatest common factor. And greatest common factor is really kind of unmultiplying things. So the very first thing we're going to do is remind ourselves about the distributive property. So there are 3 examples here where you're going to simplify by distributing the factor in front to each of the terms inside the parentheses. So pause the video right here and go ahead and do all 3 of these warm-up problems, and then come back. All right, take a moment and check your answers. And if you got any of them incorrect, you'll want to pause the video again and go back and revisit that problem. And if you still can't figure out what was wrong with it, then you'll need to write that down so you can ask me that question in class tomorrow. All right, when we're using the distributive property, we are multiplying by factors to give us a product. So a factor times a factor makes a product. There are several methods to use to factor polynomials. The method that we use is dependent on the polynomial that's provided. So today we're going to be looking at the greatest common factor, which is actually the very first thing you should always look for when you're asked to factor a polynomial. So starting with these first 3, we're just finding the greatest common factor. We're not actually doing the factoring. So to find the greatest common factor, we're looking at all of the terms, and we're looking for the largest factor of each of these. So for 14x cubed, I'm going to start with the 14, and we're going to use what we did on Friday. So I'm going to break 14 down into its prime factors. It's 2 and 7. And for the 4, I'm going to break that down into its prime factors also. And then however many they have in common, that's what we would include as part of our greatest common factor. So 14 and 4 both have 1, 2 in common. I can't use the other 2 because 14 doesn't have 2 2s as prime factors. So I'm going to go ahead and write down a 2. Now I'm going to look for variables. So looking in the 2 terms that are there, the variables that I have are x cubed and x squared. So they are both x's, so they definitely have x's in common. And when you're taking out a variable factor, you're taking out the variable with the smallest exponent. So of the 2 terms that we have here, our exponents are 3 and 2. So the smallest exponent would be the 2. So this would be 2x squared. All right, for our second one there, we have 3 terms. So for our greatest common factor, we actually need the greatest common factor for all 3 of those. So once again, I'm going to start with the numbers, and I'm going to do a prime factorization. So for 18, I think I'll start with 6 and 3. 6 will break down to 2 and 3, and then I'll just bring down the 3. So 18 is 2 times 3 times 3. For 3 is already prime. So I'll just bring it down. And for 6 will break down into 2 times 3. So now in order for something to be a greatest common factor for all 3 of these terms, it has to be common to all 3 of them. So I notice in all 3 of them, just at a glance, there are 3s. There's only 1 3 involved in this one and 1 3 involved in this one. So what I would say is common is just 1 3 to all 3 of them. So my greatest common factor there would be 3. Now, if I look at the variables, my variables are m to the 4th, m, and then the 3rd term has no variable with it at all. Since the 3rd term has no m's in it, I can't say that all 3 terms have m's in common. So for this one, 3 is our greatest common factor. Now for the third one, I've got 2 terms. There are 2 things that are separated by plus and minus signs. So I'm looking at common factor for these 2 terms. So again, I'll start with the numbers, and I'll do prime factorization just like I did before. So 20, I think I'll call that 4 times 5. 4 is 2 times 2, and 5 is a prime number, so I'll just bring it down. For 45, I think for that one I will start with 9 times 5. 9 is 3 times 3, and the 5 is a prime number, so I'll just bring that down. So looking at these 2, the only thing that they have in common is a 5. So I'm going to write down a 5. Now I'm going to go back and look at the variables. So in the first term, I've got a c squared and a d. In the second term, I've got an a c, and a d cubed. So between the two terms, they do not have any a's in common because the first term has no a's, but both of the terms do have c's and d's. So I'm going to have c and d as part of my greatest common factor. Now remember, we're supposed to use the smallest power in any term that's given there. So for c, just looking at the c's now, my power on the first one is a 2. The power on the second one is a 1. So the smallest number there would be the 1. So this is just a c to the 1 power. I'm not going to write the 1. For the d's, I've got a d with a first power and a d with a third power. So the smallest power of all the d's is also a 1. So I would just have d. So my greatest common factor on this one is just 5cd. All right, now we're going to factor these polynomials. So the first thing we have to do is find the greatest common factor for all of the terms that are involved there. And then we'll talk about how to write the other factor. So looking at all 3 terms that are here, we're going to do prime factorization on each of them. And this would be a great place to pause the video and see if you can figure out the greatest common factor for all 3 terms. You should have gotten 3x squared for your greatest common factor. Now to find the other factor, you have to take each of the terms that are here and divide them by that greatest common factor, and then write down each of the new values that are there. So I'm going to take 6x to the 4th and divide it by 3x squared. Now remember, when we're dividing these, we are dividing the coefficients. So 6 divided by 3 would be 2. And then we subtract the powers on the x's. So 4 minus 2 is 2. So the result of that division is 2x squared. So I'm going to write down 2x squared here. And whatever sign is before the next term is the sign that I'm going to write down. Then I'll do the same with the next term. So 12x cubed. I'm going to divide that by 3x squared. Again, divide the coefficient. So 12 divided by 3 is 4. X cubed divided by x squared. Subtract the powers. So 3 minus 2 is 1. So this is just 4x. Then I'm going to look at the sign that's between the next 2 terms. That's a plus. So I'll write that down. And then I have to take the last term and divide it by the greatest common factor. So 3x squared divided by 3x squared. The 3 divided by 3 is 1. And x squared divided by x squared is also 1. So this is just a 1. So this is now factored with the greatest common factor taken out. For today, we're only going to be working with greatest common factor. We'll worry about other types of factoring in subsequent lessons. All right, so now looking at the second one, they didn't set things up for us this time. There are 2 terms involved in this one. So I'm looking for greatest common factor first. My coefficients are 4 and 1. So the only thing that they would have in common is a 1. I do notice that both terms have c's in them. So there is going to be some kind of c as part of the greatest common factor. And remember, it is the smallest exponent of any of the terms. So I've got a c cubed and a c squared. So c squared is going to be my greatest common factor because 2 is smaller than 3. Now go ahead and set up parentheses like they did for me before. And then I have to figure out what goes inside the parentheses here. Now I noted last time that whatever sign was between the terms was the sign I was going to have between my terms here. So I'm just going to go ahead and put down that minus sign. And then I'll take each of these terms and divide them by that greatest common factor. So 4c cubed divided by c squared. 4 divided by 1 is 4. And c cubed divided by c squared is, subtract the powers, 3 minus 2 is 1. So it's just 4c. So I'll write that down. Do the same with the second term from the original problem. So c squared d. We're going to divide it by the greatest common factor, which was c squared. So the c squared over c squared cancels out, makes a 1, and that leaves just a 1 times d, which is just d. So the other factor on this one would be 4c minus d. So we've got c squared times 4c minus d. Okay, last two examples here. For our first one, for the first one, I have coefficients on all three terms. And I also notice that I've got n's in all three terms. So I'm going to have possibly have. Okay, so for our last two problems here, we are looking for the greatest common factor for all three terms. So I would break down the 18, the 27, and the 9, and I would find that they have 2 3s in common. So 3 times 3 would be 9. Then I'm looking at the n's. There are n's in all three terms, so they do have an n in common. And I would look for the smallest power in any of the three terms. So 4, 3, and 1. 1 would be the smallest of those. So now I've got 9n. That's my greatest common factor. So then I would take each of these terms and divide them by 9n. Now this time I'm not going to show that work off to the side. I'm just going to do it. So 18n to the 4th divided by 9n. 18 divided by 9 is 2. And n to the 4th divided by n. Subtract the powers, we would get n cubed. Next up, I've got 27n cubed divided by 9n. So 27 divided by 9 would give me 3. And n cubed divided by n would be n squared. Subtracting the powers again. Then I've got 9n divided by 9n. So 9 divided by 9 is 1. N divided by n is also 1. So that just turns out to be 1. This would be my factored form. Now for our last problem over here, the two terms that we have, only two terms this time. We've got 15x to the 4th and 27y to the 4th. Do a prime factorization on 15 and 27, and we'll find again that they have a 3 in common, only a 3. Then if I look at the variables, my first term has an x to the 4th, and my second term has a y to the 4th. Now because the base of the exponentials are different numbers, that means they are not common. They have nothing in common as far as the variables are concerned. So 3 is my greatest common factor this time. So now I'll just take each of these terms and divide them by 3. So 15x to the 4th divided by 3 would be 5x to the 4th. And 27y to the 4th divided by 3 would be 9y to the 4th. And this would be our factored form.